Week 13, part 3, looking at an example of multiple lenses where you've got lenses in sequence. The light from one lens passes through a second lens, and you have to figure out where in the world the images form in this case. So we've got a negative lens here as the first one with a focal length of minus 12 centimeters, and then it's followed by a positive lens of focal length 16 centimeters. Where in the world do the images form? So with a negative lens, a parallel ray going into this lens diverges. It doesn't bend in toward the axis, it bends away. In fact, it bends away as if it were coming from the focal point. So we'll just draw this ray heading off that direction. We don't need to draw it any further because it's not even going to make it through the second lens. It's not a terribly useful ray. Another ray we could draw is one that goes right through the center of the lens. And there's that ray, and we'll let it keep on going until it strikes the second lens. And unfortunately, it's not one of the simple or principal rays that we can figure out. It's not parallel to the axis. It's not going through a focal point. It's not going through the middle of the lens, so we don't know exactly where it is going to go. We can calculate it, but can't do it graphically. Another ray that we could figure out, and this one works right through the second lens, is one that's heading as if it was going to hit that second focal point, but it doesn't. That ray comes out parallel. And it's going to keep going right parallel to the optical axis. And when that comes into the second lens, a parallel ray into this regular kind of a positive lens just gets bent right in toward the focal point. So that's how that one will behave. This will presumably get bent, but we don't know where. It will come over and cross somewhere down here, and that's where an image will form. There's another image formed if we follow this ray back, and right there is the image that we have to begin with. This thing is very, very small. I don't know how much of that you can even see. So let's see if we can calculate where that image is, and then with that information, can we calculate where that image is. So for the first one, we use our usual equation, object distance, image distance, and focal length. So let's put in the object distance, we say is 36 here, so 1 over 36. And the image distance, we don't know, that's what we're trying to find. And the focal length is minus 12 for this diverging lens. Well, if you go through the math for that, you should come up with the image distance is minus 9. So what does that minus sign mean? The minus sign means the image is not formed in the usual way on the right side of the lens, but it's formed back on the left side. It's these rays out here that are diverging, but they are coming as if from a point back on this side. And the distance that that is away is the 9. And the fact that it's negative is because it's on the wrong side of the lens. Okay, that gives us where the image is that these rays are forming. Those rays then go into this second lens. So let's see what happens there. The rays out here are coming as if from this point that we just calculated, that's 9 centimeters away from this lens. So what's the object distance for the second lens? Well, it's where those rays seem to be coming from. So in fact, it's not 66, it would be 66 plus 9. So we take 66 and add 9 to it to get this extra distance here. And that gives us 75. So then if we do the math, 1 over the object distance, that's going to be 1 over 75. 1 over the image distance, that's what we're trying to find. And then the focal length here is 16. So now, what do we have when we calculate that one? Well, you can do the math. And the number that I got was just a little more than 20, 20.3. So that dot is at 16. If that's 16, 8, 16, somewhere out about here would be 32, or 20 would be real close to this. So I need to draw this ray coming in a whole lot closer so that it just barely misses the focal point. Real close to it. So our image will form right in there, and it's going to be upside down, but it's a tiny, tiny little image. This diagram doesn't work very well. That distance, by the way, is positive because it's on the right in the usual sense, distance from the lens. Now let's work out the magnifications. So the magnification from this first one is minus the image distance over the object distance. So that's minus, and now the image distance itself is minus 9. The object distance was 36. So we end up with a positive magnification of 0.25. It's exactly 1/4. For the second one, the magnification, we'll call this M1 and M2. The magnification of the second one, again, minus image distance over object distance. That's minus the image distance was this 20.3, and the object distance was 75. And so here we do have, in fact, a negative answer, and I got minus 0.27. It's just a smidgen more than 1/4, but it's negative. And then the overall magnification of this whole system, if you were to say 1 plus 2, both lenses together, is the product of M1 times M2. And the product of those two, when I multiply them together, I get minus 0.0. Let's make that 0.0678. So we have a very small image finally. It's what, 1/4 times a little bit more than 1/4, so it's about a 16th roughly. But it's negative, notice, so the final image is in fact upside down.